In this video, we will talk about performing of data analytics, specifically a type of data analytics known as descriptive analytics. Before we talk about the different ways to analyze data and the different analytic methodologies available, one first needs to understand that the process of data analysis is lengthy and often involves a lot of different steps. One of the most important steps in the data analysis or data analytics process is the process of data wrangling. Data wrangling may also be known as data transformation and data manipulation. In fact, 70 to 80% of a data analyst's job is getting the data in a structure and form ready for analysis. And so data wrangling is the set of activities required to clean the data prior to the analysis process itself. Data wrangling can involve several steps. It involves reading a file and making sure the file is in the right format for reading. It involves normalizing the file or converting a file into the right form, making sure columns capture appropriate values, making sure rows represent the things you want needed to represent in the analysis process. Wrangling may involve the extraction of rows and columns and creating new rows and columns, and maybe sometimes even transforming columns into new columns. These are only some aspects of the data wrangling process, and often data wrangling is really dependent on the data itself. One of the important parts of data wrangling is the process of normalization. Normalization, as it applies to data wrangling, is making sure that each row is uniquely identified and contains only one observation. Sometimes you want to make sure that each column in your table contains a unique variable, and each row in your table is an observation of each variable. Consider, for example, the following spreadsheet. One might have a spreadsheet in the form depicted up here, where each row represents multiple years and each column represents quarters in those years. Now, in some cases, this type of data structure might be suitable for analysis. For other types of analysis, we might require the structure to be along the form of the second table, where each year and quarter are a unique observation in the table. And so there are two processes, known as gather and spread, that allow us to convert one type of structure to the other and vice versa. Gather converts a table or a spreadsheet that is in wide form to a structure that is in long form. That is, going from the structure represented first to the structure represented second. The structure represented first is known as the wide form of data. The structure represented second is known as the long form of data. Spread, on the other hand, is going from a structure in the long form to a structure in the wide form. Depending on the data analytics one wants to perform, one can either use data that is structured in the wide form or the long form. Exploratory and R rely on DeepLiar, which is a package within R that allows for data manipulation. There are lots of different features and functionality provided by this package and are accessed in Exploratory through the point and click environment. Exploratory can take in a wide variety of input files, such as text files, spreadsheets, and even connect to SQL databases. When one is performing descriptive analytics, one relies on the use of tables, graphs, and maps to represent data in different forms. But before we jump into descriptive analytics, one should talk about the different types of analytics that are possible. Data analytics can be broadly segmented into four types: descriptive, explanatory, predictive, and prescriptive. Descriptive analytics are used when one wants to get a sense of the data, one wants to explore the data, and one wants to describe a phenomenon. One typically does this when one doesn't have a great sense of the data, doesn't have a great sense of the context of the data, and one just generally seeks to understand. Explanatory analytics, on the other hand, is used when one has some sort of hypothesis. One has a familiar understanding of the data and the context of the data and has hypotheses that one wishes to test. This typically involves building of models and the testing of these hypotheses. Predictive analytics is used when one wants to estimate out into the future or extrapolate out current trends or patterns in the data. Time series forecasting is an example of predictive analytics. Prescriptive analytics gets used when one wants to make inferences about the data. These inferences may help guide user behavior, might help guide managers in making better decisions. These four broad classes of analytics are what we will explore in Exploratory and how Exploratory supports each of these different types of analytic approaches. As was mentioned, descriptive analytics, through the use of tables, graphs, maps, and other summary information and statistics, help us explore the data and get a sense of the story that the data wishes to tell us. Descriptive analytics is often used in situations when an analyst may be unfamiliar with the data or unfamiliar with the context of the data. In this hands-on exercise, we will walk through some data. This data is about shipping and is expressed in millions of tons of goods that pass through a country. As part of this walkthrough for descriptive analytics, we will be going through a set of steps. First of all, we will be using a process called gather. We're going to notice that our data is improperly structured and we will normalize the data to structure it better. We will then identify specific countries or filter on certain countries and then we will then prepare a graphic showing tonnage for each of these countries for each year. We will use a line-based visualization that will depict year, tons, and the country that we are interested in. In the second part of a walkthrough, we will calculate the mean tonnage for each of these countries and then prepare a bar chart to depict the mean tonnage of these countries. Finally, we will work with case-when statements within Exploratory so that we can create a map-based visualization depicting the mean tonnage of each country. So let's get started. Let us start by creating a new project. In this new project, we would like to bring some data in. And so we would like to use a data frame, and we're going to be working with file data. This file is not going to be locally stored, it's going to be present on a remote server, and it's going to be CSV based. Information about where this file is located is present in a text file under the appropriate module for this topic. After putting the remote file URL in here, one can click OK. And the file is read from the server. Let's notice a couple of things about this file. First, notice that in the data that is being imported, we have our first header row set to be data x2, x3, x4, x5, so on and so forth. Obviously, there's a problem with this file, and the problem with the file is as follows. Our header is actually our first row of data right here. And so, while it says the first row is the header, it seems like in the data itself, there is actually one word called data that is present. And so what we would like to do is we would like to exclude this first row so that the next row can be treated as the header and every subsequent row can be treated as data. And so we're going to ask Exploratory to skip the first row, and when it does that, It then takes the next row and treats that row as the header as it is supposed to. And so we skip the first row and then treated the row after that, being the first row once again, as the header of our data. And so we have country and we have shipping tonnage through this country for each year starting from 1999 to 2013. This is a CSV file, and so we can leave the data separator as a comma and leave the other information as it is. If one clicks save, we get the option of creating a data frame based on this data, and so let's do that. Again, we are in the Summary Statistics tab, allowing us to see summary information for this data. If we click on Table, we actually get to see this data. Now, before we think about restructuring this data, I would like to first change the name of this column. It is lower C country, and I want to rename that to capital C country. Once I've done that, I can start thinking about restructuring this data. Now, when we look at this data, we know that each of these values, each of these column headers, 1999 all the way to 2013, these are actually years, and the values in these different cells represent shipping tonnage through these countries for those years. Unfortunately, for us, these column headers don't actually represent what the values in these cells are. And so this structure of data is known as wide form data. And we want to convert this wide form data to long form data. To do that, we need to add a step. So if we click on add a step, we see the option to either gather the data or spread the data. Gathering the data is used when we want to convert wide form data to long form data, and spread is when we have long form data and wish to convert it to wide form data. Since we have wide form data, we would like to convert wide form to long form, and so we should run the gather process. And so if we click on gather, we have a variety of options presented in front of us. The first thing we've got to know is, what is it that we would like to gather? What are the columns that are currently in wide form that we would like to convert to long form? And so these are those columns starting from 1999 all the way to 2013. Now, one can go about individually selecting column names, or one can select a range of column positions starting with 99 and ending with 2013. The country column stays the same. We would not want to gather that. Now, once we do this, we are going to take and convert the headers, our current headers, into a column, and these values for those headers into another column. And so we are asked, what are the names of these new columns? The key for us is going to be the column, our current column headers. And so 1999, 2000, all the way to 2013 represent year values. And the value in each of these represents shipping tonnage. And so when I change the names of these, I can click on run, allowing me to see that I have year and shipping tonnage for my data. My wide form data has been converted to long form. Now, you might think that you would need to specify this to get this. You would need to specify the key column and the year column properly to get this right. One actually does not need to. You can still leave these as key and value, the defaults, as long as you select the right columns that you wish to gather. Even if you leave them as key and value, notice all that does is it replaces the column headers to be key and value, and you can later on rename these columns if you would like to year and shipping tonnage. And so one does not actually have to specify to start off what key and value are. One can change the column names later if one wants to. The next step in our analysis was the selection of specific countries. We would like to select the three countries, Denmark, Sweden, and Norway. And so that requires us to go to the country column and create a filter. Now, because we want multiple values, Denmark, Sweden, and Norway, we are going to select is in. Equals to is an exact match. Is in allows me to specify multiple values, and so I shall specify Denmark, Sweden, and Norway. And once I run this, I get Denmark, Sweden, and Norway and their shipping tonnage for years starting 1999 all the way to 2013, giving me 45 different rows. Now, the first part of this analysis required a line-based visualization to look at the shipping tonnage and its change over time for these three countries, a line-based visualization. To do that, we shall click on Chart, and we can pick the type of chart that we don't want, a line chart. Now notice that this chart, chart 1, is pinned to data from the filter step. And so, again, we have an x-axis and we have time on the x-axis, so that would be year. And on our y-axis, we can specify shipping tonnage. Now notice that what Exploratory has done is that it has summed up for each year the value of shipping tonnage. But that was not what we were looking for. We actually want to represent the shipping tonnage of these three countries separately as three different lines. And so I can color by or group by the country. And once I do that, I get these three different lines representing shipping tonnage for or through these three different countries from 1999 to 2013. Obviously, to make a good chart, we would need to specify a title. Now, my x-axis title is already here. My y-axis title is shipping tonnage, but I'm gonna be a little bit more specific. And so this gives me my line chart, the first deliverable for this exercise. Going back to the table, our second deliverable was to calculate the average shipping tonnage for each of these countries and represent that in a bar chart. To do that, I need to calculate the average shipping tonnage for each of these countries across all these years. And so I will click on the down arrow next to country and decide that I want to aggregate or group by each country. The thing I want to group by in this case is shipping tonnage, and so I want to perform a summarization. And what I would want to do is take this shipping tonnage and calculate its average, giving me now the average shipping tonnage for each of these countries. Notice that I have a variety of decimal places here, and so I will work with the numeric function. So click on the down arrow next to shipping tonnage, work with the numeric function, and round out this average value to 2 decimal places, giving me the average shipping tonnage for Denmark, Norway, and Sweden over this time period. To represent this in a bar graph, I would go to chart. Now, instead of altering chart 1, I'm going to make a new chart. And so I'm going to click on plus and add a new chart. And notice this new chart is pinned to the data from the step where I calculated the rounded average. And so I should create a bar chart. In this bar chart, I have two options, my country and my average shipping tonnage. And so my x-axis is going to be country, and so giving me Denmark, Norway, and Sweden. My y-axis is going to be shipping tonnage, giving me these three bars. If I want these bars in a different color, I can color by country as well, allowing me to represent each of these bars in a different color. Exploratory provides a variety of options at this stage. For instance, I can choose to sort these columns by the y-axis, for instance, allowing me to represent this from highest to lowest. And if I flip this descending to ascending, I can sort from lowest to highest. If I want to change the orientation of my graph, right now it is vertical. If I click on horizontal, I can represent the graph as like this, flipping the x and the y axis. Again, to create a good graph, one needs to provide a proper title, where the x-axis is country and the y-axis is average shipping tonnage. This completes the second deliverable of our walkthrough. Now let's say I wish to represent these three countries and colorize these countries on a map based on average shipping tonnage. And so I can go back to chart and add a third chart. Exploratory provides us with the option of creating map-based visualizations. And so I can select a variety of different map-based visualizations over here. For our example, we're going to be using an area map. Now, once one selects the area map, we can select what type of map. And Exploratory has two that are built in, US states or world map. If you don't see US states and world map, you can click on the gear icon next to area type and decide if you want to install any map. And so if I click on add new, for instance, I can, for instance, add US county maps, California county maps, US city maps. A variety of different options are available in terms of maps within Exploratory. And so since Denmark, Sweden, and Norway are countries in the world, I can select world map. Now, when one selects world map, we will have the option of selecting how are these countries going to be represented. What is the key by which these countries are named? And we have a variety of different options over here. We can actually use the name of the country, or we can use 3-letter or 2-letter codes for each of these countries. And so this really depends on the way the country is coded in the data. At the moment, I have the names of the countries, but this might not always be the case. If I would want to do it simply right now, I could just rely on the fact that I had the name of the countries in my data and use the name as the key. However, I shall assume that I don't have the name of the country properly represented. And let's assume that I want to use ISO 82 standards, where Denmark is represented as DK, Norway is represented as NO, and Sweden is represented by NE. And so, what I would need to do is I would need to create a column in my data that represents Denmark as DK, Norway as NO, and Sweden as SE. So, to do that, I'm going to add a new step. And this new step, I am going to create a column. And I'm going to create a new column called the map code. Now, to create a new column based on conditions in another column, one can rely on a function known as case when. Now, to know the different types of functions that are available to us within Exploratory, one can click on function list. And if you click on function list, we see all the different types of functions that are available to us. And so, if I searched for case when, I have documentation on how case when can be used. So, I shall say map code case when. When the country is equal to, and we're going to use 2 equals to, Denmark, then replace it, use the tilde icon with the letters DK. And so when it runs into a row where the country value is Denmark, it's going to create in map code column a corresponding value known as DK, comma, when the country is equal to Norway, create the corresponding value NO, and when country has the value Sweden, insert the corresponding value SE. And so this is the use of the case when statement. And if I run this, you will notice that I have a map code column that has corresponding to DK, or Denmark, Norway, and Sweden, values DK, NO, and SE. Coming back to the chart now, I can say that my key property is going to be ISO A2, and the column corresponding to that, I should find map code. And I don't find map code, and so this leads me to think there's something going on. Why is that column not showing up? And you will notice that this map is again pinned to data from step 8, not step 9 where I created map code. So I shall unpin this and repin this to step 9. And so now my map code column should be available. And I want to color these 3 countries by the average shipping tonnage. Once I do that, you will notice that I have 3 countries that are colorized by the average shipping tonnage: Denmark, Sweden, Norway, and subsequently Sweden. This concludes the walkthrough of demonstrating descriptive analytics through Exploratory. Thank you very much. Please let me know if you have any questions.